Hello guys, in this video we are given an electric circuit question that we want to see how we can answer it. So the question reads, a battery of an unknown EMF and an internal resistance of 0.5 ohm is connected to three resistors, a high resistance voltmeter and an ammeter of negligible resistance is shown below. They were saying a high resistance voltmeter, meaning a voltmeter, it must have the highest resistance so that no current will flow through it. And the ammeter must be of negligible resistance so that it doesn't resist the flow of current. This is our diagram. We have our battery with the internal resistance R, which is 0.5. The two resistors connected this side, 4 ohm resistor and 8 ohm resistor, they are in series. Then we have this other 2 ohm resistor connected that side. So this means these resistors, these 2 ohm, 4 plus 8 ohm, they are forming a parallel combination. Look, if the diagram is looking strange, you can remake it as follows. I can put the battery here, then we have the 2 ohm resistor, 10 ammeter there, then 4 ohm, 8 ohm, then I close. The reading on the ammeter is 0.2, so it is found out here it is 0.2 amps. Calculate the reading on voltmeter, which is the V. V is our voltmeter. It's like we connected our voltmeter across the ends of this parallel combination here. So this is our voltmeter, marking it V like that. So want to see how much voltage across the ends of that parallel combination. So what we need to do, we're told that ammeter or the ammeter reading is 0.2 here. So we can use this current and this total resistance of these two resistors in series, then we get our voltage. So we can use Ohm's law. V is equal to IR. I, which is 0.2 amps, multiplied by R. R is the total resistance of 4 and 8 in series, so we're going to say 4 plus 8. This will give us 0.2 multiplied by 12, we get 2.4 volts. Let's go to 9.1.2. Total current supplied by the battery. For us to calculate the total current supplied by the battery, we need to know the total resistance of the circuit. So once we get that, we use Ohm's law again, V is equal to IR. So let us see how we can find the total resistance. We only have this series combination which add up to 12 ohms. So this side we have 12, this side we have 2. So you can use the formula 1 over R is equal to 1 over R1 plus 1 over R2. So that will be 1 over 2 plus 1 over 12. Remember, this will be 1 over R. Then by adding this one, 1 over 2 plus 1 over 12, then you simplify it. This will give us 1 over R is equal to 7 over 12. We are looking for R not to 1 over R, so we are going to swap it. That will be R, then we also swap this side. This will be 12 over 7 ohms. That will be the total resistance. Or we can use product over sum. We just say R total is equal to product of the two resistors, which is 2 multiplied by 12, because this side is adding up to 12 over 2 plus 12 like this. This will give us 12 over 7 ohms. But now we have total resistance. So total current I is equal to voltage over resistance. Our voltage across this section, we calculated it to be 2.4. So that will be 2.4 volts divided by 12 over 7. And this will give us 7 over 5, which is 1.4 amps. That's the total current of the circuit. So let me mark it IT. 9.1.3. Calculate the EMF of the battery. We have the formula for calculating EMF, which says E is equal to I, open bracket, R, which is the external resistance, plus R, which is the small R, which is the internal resistance. So our total current of the circuit, we calculated it and we found it's 1.4. Then external resistance, it was 12 over 7 plus internal resistance of the battery is given to be 0.5. This will give us 3.1 volts. 9.2. How would the voltmeter reading change if 2 ohm resistor is removed from the circuit? Write down increase, decrease, or remain the same. Explain your answer. The more you add resistors in parallel, the more you reduce the total resistance of the circuit. So meaning removal of this 2 ohm resistor, which is in parallel section, meaning we are now increasing the total resistance of the circuit. On our solution, we can say removing 2 ohm resistor increases the total resistance of the circuit. Increasing the total resistance of the circuit reduces the amount of current flowing through the circuit. The reason is that current is inversely proportional to resistance, so total current decreases. The reason is because current is inversely proportional to resistance. Then once total current decreases, the lost volts will decrease. V lost will be equal to 0.5 multiplied by current decreased, meaning the lost volt is also going to decrease. So this means lost volts decreases, therefore the voltmeter reading is going to read more voltage value because now we have reduced our lost volts. So our answer is increase.